So in this section, we're going to talk about applications in business and economics. We'll talk about these types of applications in more context later, but for now, this is about an application strictly to linear models, and in particular to what we talked about before in terms of position of two lines in the plane, what it means if two lines intersect in when we come to these linear models. And as always, because we want to make the video as short as possible, if I have something to write beforehand, I'll do that before the video starts, which means you should stop the video, write down what I wrote already, and then listen carefully what the explanation of what I wrote, and then you can continue taking the notes along with me as I start writing down. So the first stuff we talk about today is the so-called cost versus the revenue. Any enterprise or any firm or company will produce some items and they will want to sell them in the market. Producing something will cost money, and then obviously that has to be taken into account. And then selling something, it means that you talk about a certain unit price, and then of course once those items are sold, the total amount of money is what comes into the company, the so-called revenue. So the cost refers to cost of production. If you look at the scenario here, we say that a firm produces a number of items, X, so the variable will be the number of items, and there is always some cost of production. One thing to keep in mind is that in all of these models, there is a fixed cost of production, meaning that even if the firm doesn't produce anything in a given period of time, there's always some amount of money to be spent for operating the business. Maybe there is a building with utilities, rent, and so on. So that's going to be a cost, a fixed cost, regardless of the number of items produced. Then, of course, each additional item will have a cost of production. And in this case, we assume that the cost is $5. Again, these are very simplistic models because the unit cost may not be actually the same. There's also the economy of scales. Often if a company produces lots of items, then the unit price may actually be lower because of the efficiency, assembly lines, and so on and so forth. But for simplicity, let's say that the additional cost is always $5. Then what money comes in is measured by the revenue. At some point, the firm will sell the items, and let's say the price is $8 per item. Obviously, it has to be bigger than 5 if you are to hope to have a profit at some point. So one of the questions here is, how do I actually write down the cost function, the revenue, and how many items do we need to produce to break even? Or the so-called break-even point, which is simply the point where the revenue is equal to the cost. So at the very least, we should be at that level, but not below. We should be above this level. I mean, the idea is to have the revenue greater than the cost, but we should know the information in terms of how many items we need to produce to just break even, to just compensate for the cost of production. So I know after that how more I should produce to incur a profit. By the way, obviously the profit will always be the difference between revenue minus the cost, assuming that this is positive. And of course, if the same difference is negative, we call that a loss. Let's see how we write down the function. So let's denote the cost function by C. Like I said, in the cost, we have $300, the fixed cost. And then since we produce X items and each of them costs $5 to produce, there's the additional 5 times X cost. I want you to pay attention and make an analogy with, let's switch the order here. Make an analogy with the, let's write it here, with the slope-intercept form of a line. Because in many problems, we have to switch the notation from Y to C or some other letters depending on the context. But if you look carefully, the cost function is just a line in the slope-intercept form. If we look at the revenue function, that's a little bit easier. That's just the amount of money you get for selling these items, $8 each, X items in total. That's going to be the revenue. And again, if you match it with the standard form of the slope-intercept form, notice it's on the same format. And I want you to pay attention that the slopes are distinct, right? So I mean, if we look at the slope on the cost function, that's going to be 5, the coefficient of x. That's not equal to the slope of the revenue function, which is 8. So the lines will intersect. Which means it's guaranteed that there is a point where the revenue is equal to the cost, the so-called break-even point. So to find the break-even point, we simply set the revenue equal to the cost and then solve for x. So the question is, how many items do I need to produce just to balance the cost and the revenue? In this case, it's just a simple equation. So 5x plus 300 equals 8x. We can move 5x to the right-hand side. And that's 3x. Divide by 3. And that's going to be 100 items. So for 100 items, I know that the revenue is equal to the cost. And in particular, that revenue and the cost is going to be 800. So notice if I plug in 100 for x into the revenue, that's $800. If I do the same for the cost, no surprise, it should be the same amount. So 5 times 100 plus 300, that's $800. So the break-even point, again, if we write it as a point on the plane with the x coordinate specified in the beginning, that's 100, 800. Let's actually sketch the the two lines to see how they look like in the coordinate system. We don't have to be that precise. Again, just a little bit of, just a couple of points. So if we look at the cost function, so take a look at the cost function over here. If x is 0, the y coordinate, which is c, is 300. And then we don't need to be that precise. Just draw a line. Just make sure the slope is positive to indicate that the line goes up. And then if you want to put the revenue line on the same spot, just find the y-intercept, I mean, one of the intercepts, which is 0, 0 in this case. If you look at the revenue function, obviously if x is 0, the revenue is 0. So that one starts from the origin. And because the slope of the revenue is 8, which is bigger than the slope of the cost function, just make it steeper. Because the two should intersect at a point which we just found beforehand, right? So the intersection point is 100, 800. And like I said, from a business planning perspective, if you produce anything different than 100, then you're going to have either a loss or a gain, right? So for example, if you produce anything above 100 items, your revenue is greater than the cost, so you'll have a profit. Or in other words, this difference here between the revenue and the cost will be a profit. But if you produce anything less than 100, then the difference will be a loss, because in that case, the revenue is below the cost line. So actually, let's take an example. Let's say I produce 70 items. In that case, the revenue is 70 times 8, $560. And then the cost is 5 times 70 plus 300. So I replace X with 70. That's $650. So when you look at the difference between the revenue and the cost, that's 560 minus 650, and that's going to be minus $90. So obviously there is a loss of $90 for that level of production. So that's one thing to talk about as an application of the intersecting lines, if you want, from a business perspective. The second thing we want to talk about is the so-called supply and demand. And let's do that on a second page, and I'll take a moment to write down again the definitions to save some time before moving on. Okay, so take a moment to write down these two definitions. It's important to understand what they mean before we get to the part when we put them all in the equations and talk about how they look like as linear models and so on and so forth. We should mention here that the two concepts, the supply and the demand curves, are simply functions. Let's write them down here. So functions of the unit price. So we talk about some items to be produced and sold, and these two quantities, the demand and the supply, are functions of the unit price. So just the price of one item, which is the reason why we're not going to use X as a variable, but we're going to talk about P, the unit price P. So remember, when we talk about slopes of lines, this time the horizontal line is labeled by P, the unit price. The supply is essentially a measure of production level, of incentive of a production, if you want. So the number of items the seller or the producer is willing to offer at a certain price P. The higher the price, the more items are produced, because the seller is willing to put up the effort since he will get more money. So it's important to understand here that if we end up with the equation of a line for the supply curve, the slope should be positive. The bigger the price, the bigger the supply. Again, by supply meaning the willingness to offer at a given price level. The higher the price, the more items are the seller is willing to produce and offer on the market. The demand is the flip side, or the other side of the coin. The number of items the buyer is willing to buy at a certain price P. Obviously, there is an inverse relationship here between the price and the demand. The slope should be negative, because the higher the price, the less demand is, the less the customers are willing to purchase if the price is increasing, it keeps on increasing. The sweet spot between the two is the so-called market equilibrium, or the market price. So the market price or equilibrium is the price level P where supply meets the demand. In other words, where S is equal to D. Now, notice that from a geometrical perspective, these two are intersecting lines, S and D. So S and D intersect. And that's guaranteed to happen because the slopes are different. One is positive, one is negative. Then the two slopes are distinct all the time. So there is a sweet spot between the two when the lines intersect. That's not to say, so basically that's the ideal situation in which whatever is produced is absorbed by the market. The seller is not willing to have stuff on the shelves unsold. The buyer, of course, is not willing to not be able to purchase because of a certain price level. So the two competing interests should meet at a certain price when the supply meets the demand. And it's important for that level, of course, to be known. Most of the time, of course, we are not at that equilibrium, which means there is always some certain pressure on the price, depending on which one is greater, the supply or the demand. So let's take an example that it's easy to compute. Let's say the supply line is P plus 1, so S equals P plus 1, and the demand 3 minus P. Not overly realistic, but in terms of lines, notice this is a positive slope. So again, if you match it with the standard form of the equation of a line, M is equal to 1. The slope is equal to 1. Remember, we replaced X with P and Y with S. I'm putting here Y equals MX plus B just to make the analogy with the way we write typically the equation of a line. We got to be flexible and be comfortable with other types of notations. And obviously here the slope in the demand line is minus 1, the coefficient of P. The two slopes are distinct, so there's going to be an intersection point between S and D. When you set S equal to D to find the market price, basically replace S and D with their respective equations and solve for P. In this case, we can add P on the left-hand side. 2P equals to 2, P equals 1. So P equals $1 gives me the market price. And at this level, the supply is equal to the demand. So if I replace P with 1 in the supply curve, I get 2 items. If I replace P with 1 in the demand curve, I get 2 items as well, and they're equal. Let's actually sketch the two, because I want to comment a little bit on the meaning of the intersection point and the meaning of actually being away from the intersection point. So the horizontal line is P. The supply and the demand line are on the y-axis. And then so for the supply, if P is 0, then S is 1. Let's say this is 1. And then slope is equal to 1. Let's just say this is 1, the line, the supply line. And then if the demand, if P is 0, the demand is 3. And then the slope is -1. So that's going to be the demand line. And again, the intersection point is 1 and 2 in my case. So that's the market price, $1, when the supply meets the demand. So notice that, let's say the price is set above 1. In that case, the supply is greater than the demand. Lots of items on the market, not much willingness to buy. Obviously, the pressure is on the price to decrease. So it's a downward pressure. Downward pressure on price. If the price is set below $1, let's say you're here, what happens here? Huge demand or greater demand than the supply. So that means the pressure is on the price to increase, because there are far more willing people to purchase than the number of items on the market. So obviously there is an incentive for the price to increase until the two curves meet. So that's the interpretation of the intersection point. Let's do one extra application in which we go kind of differently, in which we know, let's say we know the market price, and we also know the let's call them stop loss information. So in other words, how low can the seller go? Right? I mean, how low is the price for the seller that he's willing to sell something? Because below a certain price, maybe it's not even worth producing anything. And how high can the buyer go? There's a certain level of price after which no items are sold. Because if we know this information, we can actually have an idea on how the supply and the demand curves look like. Because in this example so far, we started with the supply and the demand curve. Okay, let's see if you can make a second part or turn the page. Okay, turning the page seems still to be a problem here with the breaks. So let's take a look at problem 14. If you have the book in front of you, you may want to look at the section in problem 14. But for those of you who don't have it, let's see how this is formulated. Like I said, knowing the market price. So let's say we know the market price. Which in this problem is $5 per unit, and it occurs when 14,000 units are produced. Then, like I said, the stop loss type of information. The problem also says that at the price of $1, no unit is produced. And at the price of $19, no unit is bought. So pay attention and realize that both these information are for different things, right? So I mean, if it says no unit is produced for $1, obviously a level below the market price, that's an information for the supply. No supply, nobody is producing anything for that price because it's too low. So S is equal to 0. No unit is bought for $19, which is obviously above the market price. That's an information about the demand. No item is bought if the price is as high as 19. Because now if the question is to the supply and the demand, so let's actually write down in two columns the supply as MP, I guess, because the variable is P, MP plus B. So to write the supply and the demand as a slope-intercept form, right? Because to find the equation of the supply and the demand is basically to find this linear equation which represents both. For any line, for any equation of a line, you need 2 points. The market price, remember, is the intersection point. And so this happens on both the supply and the demand. So this value 5 for price and 14,000 for the items, that is true for both equations. So for the supply, let's write it as a system. If I replace the price with 5, so I have 5M plus B, then the supply is 14,000. On the other hand, the supply is 0 for a price of $1. So if I have 1 times M, the price is 1 plus B, then the supply is 0. On the same way, the demand again contains the same point. That's the market price when S is equal to D. So the first equation is the same. If P is equal to M, if P equals 5, then the demand is 14,000. On the other hand, if the price is 19, so 19M plus B, the demand is 0. So we solve both of them as a system by elimination and find the equation of the supply and the demand. Remember, if I'm correct, the slope that I get for the supply should be positive. The slope I should get for the demand is negative. We can simply solve them by subtracting the two, because that eliminates B. So I have 5M minus M equals 14,000 minus 0. 4M equals 14,000. Use the calculator if you want. Divide by 4. M should be 3,500. Positive slope. Go back to the second equation, for example. Plug in M, and that gives you B minus 3,500. So the supply line will be 3,500 P minus 3,500. Same way, if we subtract the first minus the second, I get 5M minus 19M equals 14,000 minus 0. This is going to be minus 14M. Divide by minus 14. And that gives me M equals minus 1,000. Negative slope as expected. Go back to the second equation, for example, 19 times minus 1,000 plus B. Move it to the right. B becomes 19,000. So the demand line, if we start with B, that's 19,000 minus 1,000 P. We already know the market price. If you want to check your work, if you set S equal to D, the price value should be 5. So you can check at solving S equals D for P gives you P equals $5. So that's it for today. Remember to go right away to solve the homework, to do the homework, because these examples are similar to the homework problems. And don't forget, because notice that I don't take too many breaks when I go through the video in the interest of keeping the size low, but I'm expecting you to pause all the time you need to catch up, because you need to process all the computation. Don't try to go necessarily on my pace if you don't want to, and definitely don't move over until you understand how I did every computation. So hit the pause button often. I'll see you next time.